Welcome to Ask and Learn.
Let's find the absolute minimum and absolute maximum values of the function f of x equal natural logarithm of x squared plus x plus 1 on the closed interval from -1 to 1. So first we note this function is well defined on that interval because first of all we see that x squared plus x plus 1 can be written as x plus 1/2 square, which gives us x squared plus x plus 1/4 plus 3/4, which in this case gives us 1. And that's exactly greater than or equal to 3/4, which is greater than 0. That is for all real number x, this expression is always positive, and so we can take the natural logarithm. So it's well defined, and it is continuous on the interval -1, 1, because the composition of these two functions continues on that interval. So being continuous on a closed interval means we know that the function attains its extreme values on that interval, and we know that those extreme values are attained at either the endpoints of the interval or at the critical numbers of the function. So we calculate the critical numbers of this function, and for that we need the first derivative, which is equal to the derivative of the argument 2x plus 1 over the argument. And that's the derivative, and because we said already that this denominator here is not 0, it's never 0, it's always positive. This derivative exists for any x, and that means that, or we can say that the only critical numbers of f in -1, 1 are those values of that interval for which the first derivative of f is equal to 0. So we gotta solve this equation, first derivative of f equals 0, and that's equivalent to, using the expression for the first derivative we found here, 2x plus 1 over x squared plus x plus 1 equals 0, and that's equivalent to 2x plus 1 equals 0, and that's equivalent to x equal -1/2. So we can say that the only critical and of course, this number is in the interval from -1 to 1. So the only critical number of f in the interval -1, 1 is the value x equal -1/2. So we know this is the only critical number of the function, and then we had to evaluate the function there and at the endpoints -1, 1. So we start with the endpoints. F at -1 is natural logarithm of -1 square plus -1 plus 1. These two values cancel out, and then we have natural logarithm of 1, and that's 0. Then we have f at 1, which is the right endpoint, and that gives us natural logarithm of 1 squared plus 1 plus 1. That is natural logarithm of 3, and that is about, not equal, that's about 1.09 86122 887. And finally, f at the critical number negative 1/2 is natural logarithm of negative 1/2 square plus negative 1/2 plus 1. That's the natural logarithm of 3/4, and that's about negative 0.287 682073. Okay, so this is the images of the endpoints and the only critical number, and from these values we know that the largest value is natural logarithm of 3, which is 1.09, and that's the image at the right endpoint. That's then the absolute maximum value of the function on the interval negative 1, 1, and it's attained at the right point of the interval. And the smallest of the values here is negative 0.287, etc. That is natural logarithm of 3/4. And that smallest value is the image of negative 1/2, which is the only critical number of the function. Then the absolute minimum value of the function over the interval negative 1, 1 is natural logarithm of 3/4, and it occurs at the critical number negative 1/2. So we can write the answer now. Then the absolute minimum value of f on the interval negative 1, 1 is natural logarithm of 3/4, which is about or approximately equal to negative 0.287 682073, and that absolute minimum value occurs at the critical number x equal negative 1/2. Then we have the answer for the absolute maximum. The absolute maximum value of the function over or on the interval from negative 1 to 1 is natural logarithm of 3, which is about 1, which is about 1.0, 1.09, 867, and that absolute maximum value occurs at the right endpoint of the interval, which in this case is x equal 1. So this is the final answer, and as a summary of what we have done here, we first verify that the function is continuous on the closed interval given. In this case, we also prove or verified that the function is well defined on that interval and is also continuous in that closed interval. For that reason, we know that the function attains its extreme values on that interval. And because we know the extreme values are attained at either the endpoints of the interval or at critical numbers of the function, we calculate the first derivative of the function and solve the equation first derivative equals 0. We verified that the first derivative exists for every number or value x in the interval -1, 1, and for that reason, the only critical numbers of the function in that interval are those values belonging to the interval for which the first derivative is 0. So we stated the equation first derivative of x equals 0, and that's equivalent to the fact that x gotta be equal to -1/2. And from that, we conclude that the only critical number of this function in the interval -1, 1 is -1/2. So we got to evaluate the function at that critical number, -1/2, and at the endpoints of the interval -1 and 1. We did that, and the largest value we found, which is then the absolute maximum value of the function over the interval -1, 1, was natural logarithm of 3, and that was attained or occurs at the right endpoint of the interval, that is x equal 1. And the smallest of these three values, which corresponds then to the absolute minimum value of the function over the interval -1, 1, is natural logarithm of 3/4, and that is attained at the critical number -1/2. And so this is the final answer to this problem.